Hello everyone, this is Reza Wazi, and in this short lecture recording you are going to learn about the basics of logistic regression. Logistic regression is also known as logit regression. It's just a different name. So when you are reading the literature on regression, you may see reference to logit regression. Just don't get confused. It's the same thing as the logistic regression. The main difference between logistic regression and linear regression is that the dependent variable here in the logistic regression can be categorical, and by categorical we specifically mean binomial or binary variable. Remember, in linear regression you are trying to calculate the linear relationship between your independent variables and your dependent variable. The dependent variable in linear regression was continuous. So theoretically, it could take any value from negative infinity to positive infinity. But not all events and things in our life are like that. Sometimes we are only interested in outcomes such as true or false, yes or no, default or not default, response or no response. For example, in the context of evaluating user response to a marketing campaign, we want to know if they are going to act on that marketing campaign or do not act on that marketing campaign. So it's a binary variable, binary outcome, whether people are going to do something or they are not going to do something. So there are many events, there are many problems in nature and in the business that follow this logic. We want to predict whether people are going to do something or they are not going to do something, or if something is going to happen or is not going to happen. These type of events and problems, they fall in the category of logistic regression, and the dependent variable will only take on two values. However, for logistic regression, when we say logistic regression, we typically refer to binomial or binary logit regression. You should know that we also have multinomial logit regression where that the dependent variable can take more than two values. It can be completely categorical. We do not discuss multinomial logit regression in this course, but you should know that it exists and you can perform multinomial logic regression if you need to. So going back to the difference between logistic regression and linear regression. So in linear regression, we assume that there is a linear relationship between independent variables and dependent variable, and the dependent variable can take on that negative infinity to positive infinity. But when we come to logistic regression, we are only dealing with two values. Yet we want to assume that there is still some sort of linear relationship between our independent variable and dependent variable. But if we are going to model it the way we model a linear regression, our results will not make sense. You know, that the readings for dependent variable will not make sense in our case. So the way that we are going to approach this problem is to use some sort of mathematical transformation to transform that linear relationship that we defined in the linear regression into a logarithmic relationship. So when you transform that linear function to a logarithmic function, now your dependent variable will transform from a range negative infinity to positive infinity, will transform from that range to 0 to 1. So you change the function, so now the results of that function, which will define your dependent variable, can take any value between 0 and 1. That's your logarithmic transformation. The process is complicated and requires deep knowledge in mathematics, which is out of the scope of this course. But if you are interested, you can go to your book. Your book explains the process a little bit in more details, but still, if you want to fully understand it, you gotta go in more mathematical oriented courses and learn from those courses. Now let's take a look at this chart in order to understand the difference between linear and logistic regression better. Imagine that our target variable is response to advertisement campaign, and we model this so that if more than a threshold number of customers, more than a certain number of customers buy our product, then we consider the response to be successful and we consider it to be 1. If not, we consider the response to be 0. And the X represents how much money we are spending on this campaign. So we can imagine that as we spend more money, the probability of success of this marketing campaign will increase. But there is no gradual transition. The outcome is either unsuccessful or successful. It jumps from 0 to 1. So as you can see, a straight line is no longer a good fit to model this problem. We need that S-shaped line, as you can see in this graph, that will go from 0 to 1 and can tell us the probability associated with the value of x, that y will be 0 or y will be 1. So this function, logistic function, will give us some probability readings for the value of our dependent variable based on the value of our independent variables or independent variable x. So if the probability is more than a threshold, the function will categorize the event as successful or give it a 1. If it is less than a threshold, then it will give it a 0. As you can see, this S-shaped curve is certainly a better fit for our data. And the goal of logistic regression is to compute this S-shaped curve. As I mentioned in the previous slide, understanding the logistic regression is not as straightforward as linear regression. So when we get to RapidMiner, when we get to modeling this logistic regression, we do not really spend much time on understanding the output of the model or the model itself. We are more interested in applying the model on the current data or on the scoring data, and then interpret the results and see what it means for our business and what sort of business suggestions we can derive from the results of logistic regression. Well, this concludes the short lecture on logistic regression.